Hello children, in today's video we are going to prove that the square root of 5 is irrational. We are going to prove that the square root of 5 is irrational. Now what are irrational numbers? Irrational numbers are just those numbers which are not rational numbers. Which is, rational numbers can be expressed as a ratio of two integers a by b. But irrational numbers cannot be expressed in this form. Irrational numbers are those numbers which cannot be expressed as a by b. Now, in order to prove that square root of 5 is irrational, let us assume the contrary and see where it leads us. That is, we are going to assume the opposite. We are going to assume that root 5 is rational. Assume that root 5 is rational and that root 5 can be expressed as a by b, the ratio of two integers. But the important thing which we are assuming here is that a by b is the irreducible form, meaning if there had been any common factors in a and b, they have been divided. The numerator and the denominator have been divided by those factors, and now this a by b is irreducible in the sense which means that there are no common factors in a and b other than 1, which also means that they are coprime. No common factors other than 1 means that the numbers are coprime. So this is an important assumption. As I told you, a by b is irreducible form, no common factors other than 1. So now let's do some manipulation of this equation which is given to us, root 5 equal to a by b, and see where it leads us. Multiplying both sides by b, we get b root 5 is equal to a. Now, in order to do the manipulation, we need to square and eliminate this root 5 because root 5 is quite difficult to handle. So, let us square both sides. B root 5 the whole squared is equal to a squared, which is 5b squared is equal to a squared. So, what does this infer? This equation 5b squared is equal to a squared says that 5 is a factor of a squared, isn't it? Because b squared is an integer and it's positive because it's a square of a number, an integer. So what does it say? 5 is a factor of a squared, or in other words, a squared is a multiple of 5. Now, if a squared is a multiple of 5, what do we know about a? Does it say anything about a? Now let's try to find out. Now a, being as we have assumed that a is an integer, it can be expressed as a product of its primes. Like a prime factorization of a would lead to the product of its primes. So let us say that a can be expressed as p1, p2, p3, so on till p, and we do not know how many prime numbers are there in the prime factorization of a. So we are assuming that there are pn primes, and so what would a squared have? What would the prime factorization of a squared be? A squared is nothing but a multiplied by a. So the prime factorization would be p1, p2 and so on till pn multiplied by the same prime numbers p1, p2, so on till pn. But we know one of the factors of a squared, it's 5, right? We know that one of the factors is 5. So this p2, let p2 be 5. Now let me rewrite the whole thing to you for you to understand better. It can be rewritten as p1 into p1, p2 into p2 and so on. And we have assumed that p2 to be 5 because we know, only one of the p2s to be 5, not both of them. We assume that one p2 is this p2, that is one of the primes of a squared is 5. So it should figure in a also because p2 is in a. So this is 5. So a as, what do we know now? 5 is a factor of a also, or a is a multiple of 5. If a squared is a multiple of 5, then a is also a multiple of 5. So a can be expressed as 5 into some integer, 5k. Now let's square both sides and find out what is a squared from this equation. A squared is equal to 5 squared k squared, which is 25k squared. But let's not simplify now. Now we have two equations representing a squared. This is 1 and this is 2. Now equating both sides, because both are a squared, equating both sides, what do you get? It says 5b squared is equal to 5 squared k squared. So if you divide by 5, the both sides of the equation is divided by 5, you would get b squared is equal to 5k squared. Or this also says that b squared is a multiple of 5, which means, by the same logical reasoning which we have provided here, it means that b is also a multiple of 5. And alas, we have arrived at a contradiction that a and b have common factor, at least one common factor, which is 5. But what was our assumption? Our assumption was that a by b was irreducible. They were co-prime, no common factors other than 1. Of course, all mean the same. But this assumption of ours has led us to the contradiction that a and b have a common factor, which is 5. And so our assumption is wrong. What was our assumption? That root 5 is rational, which is wrong, which proves that because our assumption is wrong, it proves that since a and b have a common factor, which is 5, it has led to a contradiction. So root 5 is not rational. It is an irrational number. And I hope you understand. Thank you.